let's get started. We are right on time, so I'm very happy to see all of you here for this session about Pervasive AI. Let me introduce myself. I'm Loretta Trailer. I actually work at Huawei as a cloud and AI industry specialist, advising on strategy for the development of the ecosystem in the industry in Europe. And what I wanted to talk to you about is basically today was introducing the work that we are doing at Huawei when it comes to AI and giving you an overview of the scope of what we are covering in terms of research and development from cloud to devices. And we'll talk a little bit about HEs also. So just for the sake of the session, so to give you a little bit a note on how things will be managed during this session, I will be presenting the overall idea of what we are dealing with when we talk about pervasive AI. And at the end of the session, we'll talk about any question that you have. So it will be a Q&A session, and I will be there to answer. So let's get going. So as most of you must know, right now we are living in very exciting times. The amount of advances in technologies are basically shifting everything around, and we are living in a very exciting place where global demand is actually fastened by the advances in this technology. Whether we talk about everything that can be sensed in the physical world, whether we talk about interconnection and the way that we are communicating, or whether we are talking about the intelligence that we are bringing more and more into the products and services that we are developing right now. Well, as most of you must know, AI is now considered as the new general purpose technology. And in that sense, it is truly a true general purpose technology in the sense that it's actually impacting and driving economic development and huge technological development in many areas. Among these areas, digital transformation is actually seen and observed across all the entire spectrum on the different industry, whether we are talking about public agencies or education or healthcare, media, logistic, finance, insurance, and all the way up to oil and gas and agriculture. What it does is actually creating new experiences, providing us with new services and new business. In that sense, I thought that it would be interesting for us to give you an internal view of what actually Huawei contribute to this change into the ecosystem. Of course, our vision and mission initially has always been to be able to bring digital services to every person and home and organization to make it a more connected and intelligent world. And across the many years since Huawei actually exists, we have developed quite broadly across the spectrum. And so we've gone from career products and services initially in telecoms and going all the way to providing product and services custom for enterprises, all the way back to customer through cloud products and services. And that unique positioning give us a view of the entire spectrum of how AI now can really be seen as a pervasive technology, which actually is embedded in every aspect and every actually layers of this ecosystem, whether it is about consumer layer and integration of AI into the mobile devices, or whether we're talking about AI and its impact and its usage in telecommunication, or whether we are talking about AI as a tool for development of new application at the cloud computing level. So let's start with cloud and AI. This is obviously one of a very specific and very fun topic of mine. How actually AI and cloud come together in the ecosystem to actually make things shift forward. And you need to understand that from the overall perspective, the first initial set of premises that we started to work on and really think about was actually the idea of providing more capabilities and computing capabilities to be able to support that shift towards AI. And that meant that we actually started to develop a full grade of data centers located around the world with more than 23 regions and more than 45 availability zones, allowing us to cover that huge need and request in terms of global connectivity, but also ability to compute. And when it comes to ability to compute, obviously, the first move was actually to think about the hardware component that was actually required to be able to address these very specific needs when it comes to computing, when we talk about AI. And so I think the first step for us was actually to rethink the overall architecture and think about first the initial chipset architecture, and then move forward into the whole product line. And so we developed four key actually component when it comes to data centers and cloud computing that are actually right now the key elements on top of which we're building HPC that allow us to address AI use cases. The three of them are actually main servers that are today deployed in Europe, but also in Asia and across the world, such as the Atlas 800 or the Atlas 300T. And furthermore, for bigger needs, we are talking about the Atlas 900. Huawei has been a long-term company investing into computing, and it's since the beginning we have taken a lot of pride into managing our own chipset. And so we went from the initial chipset configuration with actually the Kunpeng line to what we call now the Ascent line, which is more specified, more tailored chipset categories specifically dedicated to AI. And so right now, in terms of product line, what the world knows about chipset capabilities when it comes to AI is that one of the most intensive and efficient actually AI chipsets dedicated on the market is actually the ASN 910 and the ASN 310 dedicated to in both inference and training. And so, of course, and further generation actually plan down the line, but the overall idea was actually to really start from the beginning when we're thinking about how to best address the computing and capabilities needs in terms of AI processing. And so, of course, more than just chipsets and hardware, when you think about cloud and AI, you need to think about the whole ecosystem in itself. And naturally, not only for AI, but Huawei developed a full and rich ecosystem dedicated to cloud services, whether we're talking about containers and elastic containers, specifically because Huawei has been one of the key actually leads when it comes to contribution into platforms such as Kubernetes, or whether it is about containers with platforms such as Kata containers. It's not all about computing and computing capabilities when it comes to hardware. It's also about this ecosystem, which interconnects in between containers and elastic capabilities into virtual machines, but also databases and also obviously storage. And so one of the main I would say drawback that we heard from the community was, okay, we were able actually to build on top of your services and build on top of other cloud service provider services, but one of the things missing for the community was mainly the idea of being able to go from the initial data processing aspect to training the model and then having to manage all of these models in production, and then be able to then serve them in a very fast and efficient and reliable way across a single one workflow. And so in that perspective, the idea for us was obviously to move forward into our cloud ecosystem based on our own specific hardware to be able to provide what we have called an application layer that would allow any developers, any AI experts, any data scientists, which are not necessarily actually AI ops, to go from data to data processing and therefore model training, model management to deployment in production. And this is what we call now ModelArts. So of course, model hearts is actually thought as a way as fastening this actually training processing. And when you compare model hearts to other um, software out there, we can see the huge gap in efficiency. Of course, training models takes time, but it's also about the ability to have a high level of accuracy when it comes to the model that you have trained. And so Model Heart right now actually fulfilled that promises that we had initially to be able to deliver to developers, a very efficient actually framework that allow them to go from data to data training and then deployment in production with a high level of accuracy and in very fast and efficient contests. So of course, AI and cloud are tightly connected, but it's difficult actually to think about building cloud services by relying on these initial, I would say, key components such as the cloud instances, databases, the storage capabilities, and then furthermore, model heart and all the AI model training and management applications that are out there without thinking about the other aspect of the spectrum. Because these application, the AI enabled empowered application that we are all thinking about, well, they have a counterpart. And this counterpart actually exists on the devices in themselves. And so the initial input in print that we brought to the community was actually to start inserting within our own devices, of course, AI enabled functionalities such as master AI or AI translation or low power AR enabled functionalities. But it was not about all dealing with AI for ourselves and by ourselves. And so the idea for us was basically to think about how we could make sure that more developers, outside developers, could actually access the Huawei mobile devices capabilities to be able to build on top of it to produce AI-enabled application. And so one of the key challenges were actually the high entry of barrier that actually these developers were actually facing, but also the fact that when you think about AI, well, most of the AI experts, depending on where you're sitting on this time frame, are actually expert in algorithm, but not necessarily expert in deployment. And so we had to deal with these different issues when it comes to programming paradigm or execution mode or the way of sharing the model and executing these models on the device in itself, but also later on how this interconnection in between the cloud by itself was actually going to be made. And so in that contest, we actually created MindSpore with the idea of bringing to the community a full deep learning framework that were actually specifically designed to work and operate on mobile devices. And this actually MindSpore framework was actually intended to address each one of these key issues, among which the ability to first port AI programming paradigm from the initial onset and turn it into code. And so through MindSpore, the idea was basically to be able to allow developers, data scientists, and other actually people developing and working around AI to have the ability to basically just focus on AI writing and algorithm writing rather than just trying to extrapolate these constraints. One of the other things was actually the ability to use different time of runtime and in capabilities, and with the same runtime and with the same actually engine being used from both on the mobile and the cloud computing part, we were able through MindSpore to offer an ability to developers to be able to forget about offload graph devices, offloading graphs to devising or maximizing the computing power. And so the third issue was actually this ability to actually use one model from the devices to the cloud actually services that being developed to the edge. And in that sense, the overall purpose of MindSpore was actually to be able to make sure to offer one framework, one deep learning framework that allow developers to develop once and deploy anywhere. So of course, when we start to bundle everything together. We think about the cloud aspect of AI, and then on the device aspect of AI, we think about hardware capabilities and how actually to be able to do AI, actually you need to consider also the hardware needs, but also the software needs and how everything sit together in between cloud services and need for application developers on from the device perspective. And then there is this whole way in between, which allow us first to interconnect and share these models and also make sure that the interconnection in between devices and cloud are actually efficient. And this is where 5G come into consideration. Of course, doing it over 3 or 4G is actually acceptable, but there is more than just that. And then there is the counterparts with the development of all these interconnectivity on a day-to-day basis growing and growing. And so we need to consider also the impact of edge computing here. And so, yes, indeed, AI is actually very pervasive in a way where when you start to actually bundle everything together, you start to see that to be able to have and talk about next generation general purpose technology, we really have this huge integration in between different type of services and different abilities, whether it is on the cloud services part, whether it is on the device part, or whether it is on the edge part. And one of the key aspects on which we are working right now has been actually the optimization when it comes to 5G coverage to allow a better interconnection in between devices, but also backbone. And so we've been using, of course, and developing AI as AI-enabled software, which is customer oriented, whether it is customer oriented on the devices towards developers and developer communities, or whether it is customer oriented on the cloud part for enterprises building software themselves. But we actually turn that logic inside into what we are developing ourselves into a product to be able to use AI capabilities to optimize the communication on the 5G channels product that we are delivering. And so part of the optimization and input that we were able to deliver were bringing and making sure that the optimization were able to allow us minor 20% consumption optimization, for example, or a better range of coverage when it comes to 5G. Then when we start to think a little bit broader about when it comes to interconnection in between edge devices and central cloud, we start to see that indeed, beside the devices, our smartphones, we have all these cameras, scanners, all these devices, whether it is in health or in the cities for smart cities, they're actually getting smarter and smarter. And again, there, one of the key challenges is actually to be able to make that connection in between edge devices, cloud devices, and how to actually make sure that the model that we are deploying at the edge are actually very highly efficient. And so we've been working on this part to make sure that we offer an hardware layer which is able to deal with this type of complexity, whether it is on the device side or whether it is on the edge side. And again, these Atlas 200 and Atlas 500 are actually based on the original principle of these ascent actually chipsets, which are actually highly AI enabled and efficient. And so the last part of this is obviously when you think about it, well, you have these edge devices, which makes that connection in between the border of the cloud computing part, which is then the edge computing, and then the actual usage, whether it is autonomous driving, whether it is actually a smart scanner into your hospital. And so when it comes to our smart cities, one of the use cases is basically most of the time computer vision. And so we started to work on this high-level AI application development framework that we call HiLens, to be able to offer that interconnection in between of edge, I would say, activated device, which is highly AI enabled, and the end devices by itself, which is made AI enabled. So indeed, when you think about it and you start to really strap out and reconstruct the different layer of every services that we actually now take for normal, we start to see at which point AI is actually embedded into the day-to-day life that we are actually seeing everywhere. And so, what's next when it comes to pervasive AI? Well, we've seen that overall, through a fully integrated stack, we were able to actually integrate the different complexity and deal with the different complexity of having to deal with AI, whether it is at the device level, at the cloud services level, or whether it is at the edge level. And we were only able to do that because we had this idea, original idea of having one integrated strategy where we were able to use and rely on a generation of chipsets where we're actually from the beginning and by design AI enabled. And then started from the chipset, we started to build over the top first different chipset set operator library, which were able to deal with this kind of type of operation. Then a broader framework, which is MindSpore, offered to developer to be able to bring unified training and inference to both edge device and cloud. And then on the other side of the spectrum, on the cloud part, offering to developers and enterprises developing high, highly complex and highly efficient and highly available application, this framework that allows them actually to deploy models through ModelArts. Right now, among the challenges, I would say one of the key challenges is data privacy and how you actually embed from the beginning data privacy in the design of your model, in the design of your algorithm. And this goes through this idea of shifting from maybe this iterative learning that we've been going through for the past couple of years, where we actually infer, and depending on the confidence level of our model, we will actually correct and change the precision initially made. And we're moving actually fast forward now from this initial actually conceptual view of models and AI training and inferencing to a better approach, which takes into accountability to take into account the advances that we have right now on cloud services, but also on edge services to offer edge training and therefore have a better change of having models which fits at the better our reality. And this also brings for us a huge impact because this actually way of dealing with data is actually more respectful of data privacy. So we are moving toward now what we call federated learning, and these use cases can be seen everywhere in the industry. One of the most, I would say, colorful illustration of federated learning application and development is specifically in health, where now more and more in hospital, we are applying federated learning platform to be able to deal with this kind of complexity where we are tapping into the health data hubs that we have at our disposal, but while preserving this notion of data privacy by not moving the data by itself, but just moving around the algorithm. The other set of issues that we're working on right now, at least at Huawei, is also this idea of being able to make that pervasivity of AI more sustainable on the long term. From the operational perspective, we can see that deploying AI at the edge require to deal with the challenge of optimization, model optimization, because these models actually deploy at the edge are not actually for now quite as efficient as the one actually used in backbones. And so the overall idea for us at the R&D development is really to think about novel architectures such as binary projection coding blocks, which allow to, based on the idea of using binary neural network, to have a better efficiency into building and training actually model that will work in a very set and limited environments. Among these challenges, of course, we're thinking about different type of challenges that we'll be facing more and more while we are developing services for our own devices, whether it is thinking about semantic analysis or whether it is complexity that we are dealing with when we are thinking about autonomous driving. The overall idea for us is really to be able to move fast forward. And this is why, one of the reasons why we have actually really invested a lot into training and the development of the developer community. So right now, a part of the work and part of what we've been doing is injecting a lot of cooperation and collaboration with AI incubators all over the world to be able to make sure that not only we are spreading the word regarding the framework that we have developed for, I would say, a more pervasive and collaborative AI about MindSpore, but also about the different tools that we are bringing and putting at the disposition of the community. So this is the whole idea of how pervasive AI can be. And of course, as you have seen, AI will actually impact all of us, whether it is in the finance industry or the health industry. And we have now a wide range of panel of technologies from cloud to devices through edge services to be able to deal with this kind of complexity. And the issue is really about making sure that we have one framework, several framework, open source framework that allow us to build on top of these capabilities to make sure that we are able to develop better and more accurate models that fit the services. So this is it for me, and I'm really be happy to take notes and answer to a couple of your questions.